This conference will now be recorded.
Okay, so in the DevOps session, we have covered what is DevOps and we discussed already in detail. So in LMS, we have a 2 hours of session on DevOps. We have 8 hours of sessions also recorded at DevOps for DevOps. But today we'll get into the DevSecOps. Okay, so we'll try to understand, how this DevSecOps is being rolled out and things like that. So as part of our journey, we will discuss about the DevSecOps manifesto, which is published by DevSecOps.org, and then we'll understand why do we need a DevSecOps, what are the problems we have, and how this DevSecOps will help us in terms of increasing the software assurance, and how do we extend the practices, the DevOps, and bring the DevSecOps practices to our project. So these are the things which we are going to discuss. So yes, DevSecOps manifesto, why DevSecOps, problem being solved, what problem the DevSecOps is solving, and how DevOps is extended with the DevSecOps. DevSecOps increases software in assurances. So yeah, so what is the DevSecOps then? Then basically security is one of the very important domain for the software industry right now, because if you look at this, all the software which we are running, it's in cloud, it's in Azure, it's in AWS, it's in Google Cloud or some private or public cloud, and it is in a data center, and we all are accessing that application through the website or like browser or something, play store or app and stuff like that. So security is very important, because we do that not only browsing the website, but we do have our emails actually, we do the banking transaction, we do the UPI, we do the like lots of very critical crucial information we share through the software. So how do we incorporate security within the Agile and DevOps practices? The Agile practices which we have discussed, if you remember, where we bring the development and QA people together. DevOps practices also we discussed, where we bring the development plus QA plus operations people together. Now DevSecOps, then where we'll have to bring security people together, and not only will bring those people together, we will also become a champion for the security. That means, let's say if I am doing the coding, I should be doing the coding with secure coding actually. If I'm doing the testing, so I'll be performing the security testing also. If I'm doing the operations work or infrastructure work, I will make sure that the infrastructure is, secured and things like that. So, how to incorporate security within Agile and DevOps practices? That concept, if you put it up together and you want to name it one keyword, that is called DevSecOps. So DevSecOps, as per the Shannon list, the purpose and intent of DevSecOps to build on the mindset. Yeah, mindset. Remember, in the DevOps also, if you remember, we were focusing on the mindset. So here, the idea is to set your mindset. Set your means you are a developer, you are a QA, you are an infra guy, you are an architect, you are a designer, you are doing any contribution. Set your mindset that you all are responsible for security. Everyone is responsible for security. It's not like there's a security team out there. After that, once we do the code lock-in, and then QA validation is done, then I will give that product to those guys. They will do the security. No, it's not like that. We'll have to set up a mindset like everyone is responsible for security, irrespective of what kind of contribution you're making to the software development and release process. So yes, mindset that everyone is responsible for security, with the goal of safety, distributing security decision at speed and scale to those who hold the highest level of context without sacrificing the safety required. Again, this is the one of the standard definition for DevSecOps. Now, DevSecOps.org has come up with a manifesto also. They usually meet as a community initiative, and they decided like, okay, we'll have a certain manifesto and we'll try to implement within our projects. What are the manifesto they have? So they say, let's do one thing, leaning in over always saying no. That means let's try to do something in terms of incorporating the security practices, rather than saying that okay, this is not my work, this is not my domain, this is not my scope of work, let them do by someone else. It's like that. So bring that mindset in your team. Data and security science over fear and uncertainty and doubts. That means if you want to implement the security, then talk in terms of data. Data means build the data, set up a very robust observability platform, so where you get the data like log data, trace data, and all these different types of data, you get it, and use the algorithm, use the science, use the process, use the practices over the fear, uncertainty and doubts. So that is a manifesto. Now here it says, hey, open contribution and collaboration over security only requirement. So many projects, if you go and see that, they will have a one security as a like a requirement as part of the software development phases. Okay, so they'll say, okay, we do the functional testing, and after that we'll do the security testing. So that's one of the requirement for your project. But you know what, you should rather incorporate the open contribution and collaboration. That means, see, security is not a something like if you do this one, your product will be secure. The more you are open to the whole world and sharing the problems what you are experiencing or maybe others are experiencing, the more better, the more secure world we can create. Okay, so open contribution means, see, whatever the issues which you are experiencing or others experience, we should come back and come as a community and share that, and we should collaborate each other in a such a way like no security issues should be should be not, we should not be, like you should keep in the hidden things. The moment you talk about the security problems, people will come, they will work together, collaborate, and then other people also can safeguard themselves. So if you start having that kind of mindset, it will be very good and easy to implement the DevSecOps in your projects. Here, consumable security services with APIs over mandated security control and paperwork. What exactly I'm trying to say here? Let's keep the security as a practice. Let's keep the security as a service on an API. For example, let's say you want to do the code analysis. Okay, there is an API for it. I will send the code. That API will give me the audit of it. Something like that. Or maybe some, I want to do the dashed, I want to do the rashed, I want to do the many other stuff which I'll come slowly, and I'll introduce all this keyword. So everything should be as a service. I want to do this one. I want to scan my source code. I want to scan my runtime environment. I want to scan my sorry my host machine, my container. I want to audit my images, Docker image. So anything which you want to get it done. Maybe I want to, I want to scan my traces. So everything it should be as an API service. Okay, rather than some audit tool, some Excel sheet, some documents or something like that. Business driven security scores over rubber stamp security. That means what kind of business you are into, and you should define the security or parameters based on your business, rather than you, okay, no, you have to do this and something like that. Red and blue team exploit testing over relying on the scan theoretical vulnerabilities. That means you should be having a team which will do the exploit testing, so multiple teams, and as like a hacker, or as a as a the someone who can find out the problem in a software and stuff like that, rather than only relying on the scan of the source code or runtime environment. Also 24 by proactive security monitoring, that is also we call it observability. Shared threat intelligence, that means whatever the threat you are experiencing it, please share with your community, whole the world, so we can fix it together rather than keeping it hidden. Compliance operation over clipboard and checklist. So these are the 10 manifesto programs which we have, I think 9, which is shared by devsecops.org community. So yes, because we are transitioning from the waterfall to Agile to DevOps, DevOps, and then from now DevSecOps. So I'm not discussing the Agile and DevOps because we have spent already time on it, but DevSecOps. So let's say what you're going to do. So you know the DevOps well. You do the planning, coding, building, testing, releasing, deploying, operations, and monitor. Everything you do as a one team. Maybe you are performing something else, like say maybe you are more contributing towards the code of the product, maybe someone is contributing more towards the testing the product, or maybe operation infrastructure CI/CD. But if you want to incorporate, if you want to merge security with the DevSecOps, then what are the things you are going to do? So these are the things which you can see on this slide. We should do that. So first thing, let's start with the planning. So the first thing which you should start doing it, threat modeling and coding standards, and that is what I am going to cover next session actually. So next topic I am going to talk about what are the threat model, what are the coding standards, what are the different practices which we have, which you can incorporate in during the planning phase in your projects, which will help you to implement the DevSecOps. Now, during the coding time, you can do the static code analysis. This is something which we have done it already using the SonarQube. Okay, so this tool is already covered, but yeah, we will discuss more and more and come up with a list of security checks, security rules, which we need to inherit. Now, third thing, vulnerability scanning, then penetration testing we have to implement. One tool in terms of compliance validation, then we need to find out some of the tools for code signing validation also, and then many tools in terms of monitoring, detecting, responding, and recover. So here we have our tools like monitoring tools like Datadog, New Relic, App Dynamics, and Elasticsearch, Grafana. So all these things, PagerDuty, Rundeck, detect and respond means Rundeck you can use for the troubleshooting. So many tools are there which we'll discuss in this sessions as well. So yeah, security as a code. So now I've been telling you in the DevOps also everything we are doing as a code. So yes, security implementation is also should be as a code. Like you have to write a code for securing the code. So something like that we have to do that. So code review becomes code review. Patching becomes build a new environment and deploy. Incident response become incident avoidance using threat modeling. So code reviews become a code review. That means instead of doing the code review, you will get to know, okay, what are the problems which you have in the code. How do you get to know? So we have many tools which we can implement, like a SonarQube. We have Fortify and stuff like that. So some of the tools which I'm going to teach you, some of the sessions we had already. So like that, patching becomes build a new environment and deploy. That means what? Any idea? Any clue? What does that mean? Patching becomes build a new environment. What exactly that mean? Meaning of it? So here that is where that you have to bring the container technology. So remember that when we do the patching, when you are running application in the physical server or virtual servers, but instead you when you want to deploy the new application, or maybe you want to deploy the version 1, version 2, or major or minor version, then you start creating a new container, new pod in Kubernetes rather than patching that. So that's one thing. Incident response become an incident avoidance using threat modeling. So what we are trying to say, instead of getting the issues, getting reported, and then fixing the working on the issues, you do one thing: create a threat model, what kind of issues you may have in your project, and before you getting that issues only, create a model in a such a way, like you write a code in a certain ways, you set up environment in a certain ways, so it can be avoided. So these are the practices which we have to bring into the things. Again, you have to have a robust CI/CD practices in order to do that. And in every phases, let's say as part of the CI, you do the source code analysis, build, unit testing, acceptance testing, and many things. You have to incorporate that all these coding practices in a CI itself. So you cannot say, hey, I'm going to only implement the CI/CD for the DevOps, but we have to incorporate the security practices in each phases. Okay, so let's say if you're doing the code analysis for the finding of the bugs or maintainability issues, now onwards you have to add you have to add how to do the security scans also as part of the SCA. During the build, you need to do the dash, like you need to find out, do we have any security vulnerabilities in the compiled code during the unit testing. So you have to set up acceptance testing to incorporate the security practices as well. So that is something which we have to bring a practice. So what are the benefits of DevSecOps? So here, if you look at this here, uh, some of the questions which you find is, where is DevSecOps appropriate? Okay, so DevSecOps is very suitable when you have already Agile in place, existing DevOps in place. If you want to implement the DevSecOps, before that you have to implement the Agile, then DevOps. You should be having many release per year, some automation in place, and then DevSecOps will be helpful. If you are still in waterfall model, highly regulated environment requires lots of approval, few releases per year, and zero automation in place, then you should not try the DevSecOps. Okay, so we have Shivam. He's a software engineer and he has worked with for Kotokas for 3 years. Now Shivam wants to introduce DevSecOps practices. Okay, so let's say if he wants to introduce the DevSecOps practices, how can we help them? How can we help them? So some of the information, some of the things about the Kotokas, let's say Kotokas is following the Agile, Kotokas is following the DevOps, and you have tight release deadlines due to new customer wins and stuff like that. So how do we implement the DevSecOps, and what are some benefits what Kotokas you may have it? So here some of the benefits which you can have it because of implementation of the DevSecOps, which includes security issues are found earlier in a life cycle. That is one thing. So which is reducing the cost of remediation rework, reducing risk for Kotokas and customer, increased team collaboration, reduced time for rework for security vulnerabilities, consistency in approach, continuous security, increased compliance level, secure by design, better and automated security testing, helps compliance with various laws such as GDPR and CCPA, which is based on the USA. So this is a very good slice actually. If you look at this, if you implement the security, that means DevSecOps at the early stage, look at your cost actually. So if you implement the DevSecOps during the design, coding, integration testing, and acceptance testing and production, then cost of the production will be much lesser, compared to that if you introduce later on the time. Let's say if you introduce the DevSecOps at the design stage, then your cost will be, you look at this in this image that, and if you introduce the security at the production stage, then look at this how much cost you'll have to bear. So this is some of the advantages of the DevSecOps. So in DevSecOps, what are the roles and responsibilities you have? So one of the roles which we have is the tooling. That what are the tools we are going to use it, and how can we integrate the CI/CD pipeline? How can we integrate the security practices during the scan, build, UT, packaging, deployment, archiving, testing? So all this thing is a part of it. So that most of the time DevOps engineer or software engineer will take care of it. We should be having also on centralized software where we are managing the vulnerability management. That means no matter what kind of issues you have in the code, it can be security, different types of security issues, that those issues must be managed somewhere, and we should know that what is the status of that issues in the source code, so that it can be done using that. That we call it a vulnerability management. So which tool you can use it for this? So SonarQube you can use it for this, which is a part of the sessions already. Application security. So here you need someone specialized engineer with a focus on security fixes and compliance. Again, someone who need to make sure that government policies and the organization policies and the code standard, code compliance is in place and not violating anything. So these are the things we have to for this. These are the roles and responsibility we need it. Now, how do we adopt the DevSecOps practices in a development life cycle? So that is something which we have to do that. So again, look at this here, positioning DevSecOps in your life cycle. So this is the same image again we are showing you multiple times. So yeah, so you should set up a team and set a process in a certain way, like you are doing gradually something and the progress should be visible. Okay, so let's say you have a 200 or 500 of bugs, security issues found out by SonarQube scan. So there should be consistent progress in it, and it should be visible on the dashboard. Also, you're going to decide on the maturity level, like, okay, what are the standard and maturity level for your product in terms of security, in terms of culture, in terms of security, in terms of program outcome and security priorities and all. You're going to decide on the maturity model. So there's so many models already in place, but yeah, if you, it'll be great if you come up with your own model of the security, because each project in a way is unique and distinctive, and different model has to be implemented, depends on the things. So how do we design DevSecOps for the planning, coding, and building SDLC phases? So during the planning, during the code, during the build, what are the things you're going to do? So of course, as I discussed, during the planning, you can implement the thread model and coding standard. During the coding, you can implement static code analysis. During the build, you can implement the uh, vulnerability scans also. So these are the things you can do that. So what is the threat model? So threat model, which we will do in the planning phase. Threat modeling is a process by which potential threats such as structural vulnerabilities can be identified. Okay, so here you are doing in the planning stage itself, you are trying to find out, okay, what kind of issues you may have in future on the software. So that's called threat model. So threat modeling is a process by which potential threats such as structural vulnerability can be identified, enumerated, and prioritized, all from a hypothetical attacker's point of view. Okay, so there are many threat models, which is we have one of the threat model which is very popular, which is called STRIDE. Okay, so this was recommended by Microsoft. So STRIDE means spoofing, tampering, repudiation, information disclosure, leakage, denial of service, and elevation of privileges. So this is the model which is very popular, and we, during the planning phase of your software development itself, you need to decide what are the possible ways where your software will be tampered, spoofed, leak, DDoS, and elevation of privilege and stuff like that. So this is a very popular model. Again, we'll have one session dedicated to this, to discuss more in detail about this STRIDE model. There is another thing which we have to do during the planning phase, which is called setting up the coding standard. So there is a one very popular model which we have for setting up the secure coding standard, that is called CMU SCI model. Okay, and they advise the top 10 secure coding practices, which includes validate input, head compiler warning, architect and design for security, keep it simple, default deny, adhere to principle of least privilege, sanitize data from other system, practice defense in depth, practice effective quality assurance, adopt a secure coding standard. So these are the practices which we have released by CMU SCI. So now after this, during the build phase, what you're going to do during the coding, and during the build phase, what you're going to do. So during the coding phase, you can do two things. One is SAST, another one is SCA. So what is the difference between SAST and SCA? So SAST, which stand for Static Application Security Testing, SCA, which is stand for Software Composition Analysis. So what is the difference? So see here, if you have your own code, the code which has been written by your own engineers, there you do the SAST. So examine source code to identify weaknesses that can lead to security vulnerability. That process is called SAST. Okay. Now what is SCA then? So SCA basically, so nowadays if you look at that software development process, you have lots of open source product which with intention, without intention, developers add in your product. Now maybe your product, your code is very standard and they have no as such issues, but if you adding the open source solution, you may be violating the copyright, or maybe that code itself is, you have a security issues. So you did the scan of your source code, but what about the open source code which you have used to run your application? Did you do the analysis of that code as well? So that process which analyze the open source component against the known vulnerabilities. That process we call it SCA, software composition analysis. And for that we do have a software X-ray from the JFrog is a part of this session itself. So I'll teach you some classes that tool also. So yeah, so some of the features of the SAST, which includes read source codes, language specific scanner, like for different languages you have it. False positive can be handled fast and automated. Find weaknesses early. Now there are list of SAST tool which is available, which you can see that link. So you will have that link for a list of SAST. In our session, I am teaching you SonarQube. I have added SonarQube for that. So now, what is after the SAST and SCA? What you're going to do? So we're going to do the DAST. So what we are doing in the DAST? So during the build phase, you want to do the DAST. Okay, vulnerability scanning. So you can do SCA and DAST together in that during the build phase. So here we have discussed already what is the SCA stand for. Which will check the open source component against the non-vulnerability during the build time. That also, and apart from that, at DAST we have a dynamic application security testing, which basically vulnerability scanner runs on the compiled code basically. So because it's happening during the build stage, so that is called DAST. We have 45 Wedge Inspect actually, which will I'll be teaching you for DAST. There are a few more tools which we have, which I'll cover that during the sessions. Okay, so now what are the how do you design the DevSecOps for the during the testing and release and operation phase? So let's understand this. During the test phase, what you can do, penetration testing. So here you have a different types of testing. Here during the test phase you can do that. One thing you can do the penetration testing, which is very much manual. So that for that you have a blue red team, and you can ask them to create a very wide open testing, so it will help you to penetrate into the software. You can also have a load testing, DDoS and stuff like that. So one of the tools which I have taught you, which is called JMeter. Okay, so which you can check that to DDoS attack. By the way, there are so many other tools also to avoid the DDoS attack. In order to create a load, you have a JMeter, but in order to avoid the DDoS attack, we do have many tools. Mostly tools are built in the cloud itself and stuff like that. Fuzzy testing also you can do that. So what is a fudging? So fudging basically is a one of the ways of testing, okay, where you can automate is like a fudge testing is an automated software testing technique that involves providing invalid, unexpected, or random data as input to a computer program. Okay, so the program is then monitored for exceptions such as crashes, failing built-in code assertions, or potential memory leaks. Typically, fudgers are used to test programs that take structure input. So last one, you can combine some of the modules for the security during the integration testing also. So that is one of the good practices. Now during the deployment phase, what you are supposed to do? So you are supposed to do SSL testing. There are so many online applications also, SSL testing, that means certificate testing. Ensure all the transport security layer certificates are valid. And also during the deployment phase, you have to do the application hardening. So application hardening means make sure that your application server, web server, database server, Linux server, containers, runtime environment like a Docker, Kubernetes, these all are application and platform. You have to harden it. So there are lots of practices which you need to follow. There are many auditing tools are available for checking that each and every different platform, which will help us to do the hardening. This is one of the popular website for SSL testing. These are the popular images at AWS, which is hardened image actually. That means these images are having designed in a certain way to run applications for the production ready application, and hardened to a state where there is no other utility which will help hacker to get into the system. So that is something which you have. This is on AWS, by the way. These are on marketplace, which you can buy it also. During the operation phase, what you can do? So you can design that compliance as a code. So check against approved baseline, eliminate any deviation from baseline, verifications and monitoring also you have to do that. So basically, in short, I call it observability. So you have to set up log monitoring, infra monitoring, trace monitoring, synthetic monitoring, RUM monitoring, all this thing monitoring you have to set it up using the different tools, and you have to have a better alerting mechanism, dashboarding, run book. That means ad hoc you want to troubleshoot and get the information done from the system. So those are the kind of tools you should be having it. So some of the tools and which I'm teaching you as part of this session, I think New Relic, Splunk, Datadog, AppDynamics, Elastic. So many tools are there which will help you in terms of setting up the observability. So yeah, these are the verification and monitoring. So guys, this is a look at this the DevOps CI/CD pipeline for the DevOps, where you now you know that what you are going to do that. So when you design the DevSecOps, during the plan phase you set the standard threat model. During the coding phase you set up the SAST. During the build phase you set up the dashed. During the testing phase you set up the penetration testing. During the release you have a compliance as a code, deploy segregations, operation login, and monitoring SIM alerting. So these are the things you have to implement, you have to design with the help of multiple practices and tools to implement the DevSecOps. Is it making any sense?
Yeah, Rajesh, it is. Rajesh, can you put this in the chat, a screenshot of this? This is a very
Yeah,
quick reference.
I'll share the slides itself to you.
Okay, yeah, this is making sense. This is good.
So these are the things we have to do that.
Yeah.
Okay, so this is a Xavier Labs. You can see periodic table for DevOps tool. If you look at this bottom section, which is in the blue bottom section, those tools are basically popular DevSecOps tool. So let me name it. Some of the tools I have added in this sessions, but for SASH, Checkmax, for Signal Science, Black Duck, SonarQube, HashiCorp Vault, you have Snort, Tripwire, Savak, Varacoda, Fortify SCA. So out of which I'm teaching you Fortify, HashiCorp Vault, SonarQube, and all these other tools are there. So, by the way, these tools, whatever you see, most of the tools are paid one. But I do emphasize on the open source tool or more actually. So I'll cover many open source tool. Basically, many tools I have added in a DevSecOps from the CNCF website. So because we all are now, we know that we all are running the application in the Kubernetes container. Most of us now, and sooner everyone will be migrated to the Kubernetes. So securing the Kubernetes environment is very important, and for that we have many open source tools for that. Okay, so some of the myth which we have, I'll just ignore it. This one. So yeah, so myth I have just ignored it. Now let's focus on the automating the security testing, because application validation is very important, and during the testing itself lots of testing can be implemented. Okay, so these are the things which we are going to understand now. So how do we do that? How do we convince our team to set up automated security testing? Because remember that DevOps itself, it says you have to automate all the most of the test cases. So DevSecOps also, which include the testing, where you have to automate the security testing actually. So it's not like, oh, you're going to do all the security testing by manual and stuff like that. So what are the things you're going to do? So first of all, find out the approach, then how do we perform, and then implement. Simple thing. So approach which we discussed, some of the approach, and now we'll try to perform, and then some of the things we are trying to implement. So what is the automated security testing? So testing, typically what we do, we have a certain test path, certain testing methods, and certain security testing types. which we have, and everything we put it up together. Nowadays there is a one keyword which is very popular, and I don't know whether you hear it or not. TDD, test driven development, test driven development. So now on the same line, instead of TDD, you just talk about the TDS, test driven security. So what you are doing, you are extending the TDD and to write the security along with it. So that means, in simple way, if I say, let's say if you define security requirement, and then when you write a test cases, so for the same time you write the test cases for the security also, verify the test initially fails, and then implementing the control and mitigation, and verify that test passes or not. So for each and everything, when you write a one test case for the functionality, you must write one test cases for security. So the moment the requirement is created, test case is written for the functionality, test security test cases has to be written for the TDS also. So this is the approach you should try to follow. This is similar to test driven development, forces team to think of security beforehand, and these are the practices you have to set up. It's not like tool will be implemented for this. Therefore, security has to be defined, and this is called happy path testing. Okay, so yes, different test paths. So we have a positive testing, which is called happy path, the one which I talked about, the TDS, negative testing, sad path, bad path, manual testing, which you do that. Okay, so negative testing is difficult. So for that, how do you know what is not supposed to do? Instead of a set of inputs, there are unlimited different inputs. Output does not always show the error, sad path. Now, this you might have seen, like we discussed in the previous session during the design of DevSecOps. So two method of testing: static testing, dynamic testing. Static testing, which include, and when we say testing, including the security. So the static testing, nothing is executed; it's a source code. So source code review done, configuration review done. Dynamic testing, running code, you are doing the security testing for the running code and application. Dynamic application security testing, network vulnerability scanning, and so on, you do as part of dynamic testing. Okay, you can do also one more thing, which is called vulnerability scanning, to find out the vulnerability issues in the applications. So try to stick to the TDS. You have to research a little bit more on the TDS first. Build that understanding of TDD, then TDS, because you have to convince your team for the first TDD, and then you can implement the TDS. So this is all. This is how you start writing the code at each level for testing the security for your product. So TDS is the right approach, recommended approach for everyone. So apart from that, what you can do during the static application security testing, so you can use linters also. So what is the linters? Anyone have idea what is the linters?
No.
So linters basically, see, linters basically, it will check, do you have any uh, do you have any syntax issues? Do you have any linting issues? This means space, paragraph, all this thing you give it, right? So that will check. This will also check the code for the password, certificates, some variable which you have defined but never used it. Some of the, let's say, database connection you have open up but you never closed it. So these are the things will be done by the linters also. So there is one linters which I don't know whether uh, I covered in the SonarQube session also or not. So here, static source code analysis, that is a SonarQube, but there is one Sonar linter is also there. By the way, there are so many linters are available in the market. So you have to do that. So this is a most of the time linters are inbuilt with the IDs only when you write a program. So that way they keep suggesting you, hey, you did this wrong, that wrong, or whatever it is. So these are the things you have to implement during the static application security testing. During the dynamic application security testing, you can dynamically source code analysis, that is I'll do through the Podify. Fuzzers, you can do that. Attack proxies, ground you can find out where it can be more attacked and things like that. Okay, so vulnerability scanning. So what is a vulnerability? So a weakness that can be exploited of applications. So this is the something which we have. Now, in order to find out the vulnerability scanning, you can check at many places like a fingerprints assets, like somewhere you are trying to get into the system, and somehow some of the ways you are getting into the system is application, and you are trying to log in, and you logged in, and you reach to a place where you are not supposed to reach that. So something like that, you have to find out which are the sets which is available for that. In just list for known vulnerabilities, if you should also find out the place where you people are reporting the latest vulnerability, and whether you are addressing that or not. Also, you are trying to create a place where you have all the vulnerability listed and your team is working on it. Compare the set with the list. So there are so many scanners are available which will help you to scan the vulnerability, like network vulnerability scanner, container vulnerability scanner, third party library scanner, and so on. Okay, so manual versus automated testing, and I'll just skip it because we understand that what is the pros and cons for it. Now this is very important. So if you see that in DevSecOps model, the tools is not important. So the mindset is important. Practices is important. So as I said, like DevSecOps enforces that security will be implemented by everyone. Everyone should be responsible for it rather than someone or tool specific. So that is very important for this. So I'll just ignore some of the things. Mm. Yeah. So now in the security testing, someone will ask me, hey, what to test then? So you have to test your code. You have to test the container, because most of us nowadays we are running the containers and infrastructure. So these are the things you have to focus on it. For the code, you need to check readability, maintainability, clarity, insecure pattern, hard-coded secret, insecure third-party libraries. So these are the things you have to look at it. But are you going to look at it manually? Yes, maybe. If it is a peer code review, manually, if it is allowed, you can do that. Automated ways, anyways, I've been discussing also. What to test to code containers infrastructures in the containers, what you're going to check. So you're going to check the poison docker images, insecure third party software. You're going to check whether your containers is coming from the hardened image or not. You're going to check the integrity and verification for the images. So all this thing, infrastructure, what you can do that. So check that your OS is hardened or not. Okay, so there's a process to make the harden. You should check that also configuration error. Should also see that server and network vulnerability, whether it has been blocked or not. So these are the things to check, and so on. So yeah, so here I'm trying to say, in order to create a CI/CD pipeline, all this thing you have to implement. Linters, we have what to check. So formatting, readability and clarity, hardened secrets and all. During the commit also, you need to check that maintainability of the code, clarity, insecure pattern, hardened secrets, insecure third party libraries and stuff like that. During the build, dynamic scanning, attack proxies, fuzzies, configurations error. During the deployment, you're going to check compliance check, runtime defense, hardening. Okay, so basically, see, I just said, like, there's a huge amount of practices to be followed in order to make your application secure. And if you start thinking about yourself, like, am I going to do all this thing, that is where you start feeling pressure. So the idea behind the DevSecOps is, see, you identify which area you are working. Let's say you are architect, you are working the planning or design or development or testing or operations, and find out which are the areas where you can contribute. So the idea for the DevOps is to make change the mindset of everyone in your projects, and stating that everyone is responsible for security, and whatever the work you are doing, that first of all try to implement the security in that work, and same time try to integrate with other phases also. So that way you can build this very stable pipeline, secured pipeline for your software development. So this is the stuff. Okay, so this is the things which I wanted to talk about it. So guys, did you understand that what are the things we are going to do as part of implementing the DevSecOps? So there's the two slides I would like to highlight one more time, and that
Yeah.
is, so you decide like where at what phase you are, planning phase, threat model, and set the coding standards. Coding phase, robust static code analysis tool, linters, and all stuff like that. Build phase, check the vulnerability. Testing phase, penetration testing, fudgers, and stuff like that. Compliance validation during the deployment, code signing, validations, and all. During the operation phase, harden infra, harden runtime, monitoring, detecting, respond and recover. Now, this is also very good slides. So this will also help you to understand what you're going to do. So now the plan is very simple. For each phases, I'm going to teach you at least one tool for it, because see, you may be doing some limited work, but when it comes for the recommending the entire things, probably it will help you to convince the team for implementing all this thing. So I'm going to start with threat model, and then SAST one tool, DAST one tool, penetration tool, one tool, logging, few tools we have. SIM we have was planned for this, and segregation and compliance also. SCA we are going to use JFrog XA. So basically for each and every problem I'm going to teach you one tool. On top of that, you have to implement the practices. So it's not like, remember that tool is only playing the 25% of the work. More 75% of the work is the people who's going to contribute. So this is the DevSecOps, guys. Any questions? Any confusion?
No, Rajesh, not so far.
Okay, so what we are going to get started with it.
Hey, Rajesh,
This one.
one, yeah, yeah, I just have one question.
Yeah.
I have recently learned about, I mean, I've got some knowledge about CSPM tools like Prisma Cloud, which also is an overall DevSecOps platform in itself. It is a SaaS-based DevSecOps platform. So, I mean, all of these things like the SAST, DAST, pen testing, everything,
Hmm.
uh, would that tool be able to do all of this? I mean, here,
See,
for example, we are using different tools for every phase. Do
yeah.
you have some
So
insights about that?
to be honest, yeah, there's a lot of tools actually in the market.
Mm.
If you look at my blog also at the DevOps School, I have listed down more than 300 tools. Now the
Mhm.
question was like, are we going to cover 300 tools? Everyone is having some different tools to be, with experience with the different tools. So
Right.
what I did actually, I blindly opted for. Let me tell you my things. What I did
Yeah, yeah,
when
sure.
I was designing the DevSecOps, I blindly opted for the tools which was recommended by CKS. Now, what is CKS? So this is a CKS, and certified Kubernetes security specialist, because I know
Okay.
that all of our applications is going to be on Kubernetes and container, and this
Right.
certification basically helps us to help us to remind all the practices what we should do to implement the security, from the infrastructure to container, container to application, application to the operations, development, build, every
Hmm.
phases. So
Yeah,
you
yeah.
have around 20 to 30 tools which I mentioned in the DevSecOps, that is added and I've taken from this curriculum only.
Okay.
And they have added lots of open source tool, and which is a very popular in a kind of way. But you know one thing, let's say if you name out the some of the paid software, now we know
Hmm.
that we cannot train you that for that software.
Right.
So it's
Right.
a waste of it's a project specific software, and hardly few people know about that. There's no information in the public domain, so it's very
Yeah.
difficult to train on that software.
Got it. Got it. Okay.